This is Vega. Today we're going to be looking at Callisto. Some little details that are interesting about the place that you may find interesting yourselves. So, as a youngster, I used to look in the sky and sometimes you can imagine, you can see Venus, perhaps Jupiter, the Moon, maybe even Mars. And you can picture in your head, well, we're on the Earth, and look at the Sun and try and make a 3D model of the solar system in your head. Well, that's what I used to do anyway, perhaps you did too. So how does that fit in with Callisto? First of all, let's just get a bit of an idea of the size of Callisto. Here's the Earth down here, obviously. The Mars is quite a lot smaller. I like to think of them as being three tiers of the larger rocky bodies. That you've got Earth and Venus, both of which are similar in size. And then you've got Mars, Ganymede and Titan, which are also fairly similar. And then Mercury, Callisto and Io, which are also similar. So it might be considered that third tier of rocky objects. Of course, we're talking about the diameter and the radius rather than the mass. The mass of Mercury, of course, is 3 times that of Callisto. But anyway, let's have a look at a few interesting things. So if we were to show a scale diagram of Callisto, those of you that know will know it's the furthest out of the Galilean moons of Jupiter. One, I feel a bit sorry for Callisto, it never gets mentioned very much because it's often second best in much stuff, behind Ganymede in size, second largest moon of Jupiter, and so on. But anyways, this is why I'd like to give it a bit more focus. Its orbital radius, there as you can see, is 1,883 kilometers. Of course, Jupiter's radius is 71,500. Callisto, this isn't to scale yet. It's just a mere 4,000. So that's the sort of scales we're going to have to put on the diagram. Let's have a look. So here's Jupiter again. Don't forget that the radius of Jupiter is 71,000. This is as best as I can draw to scale. And if we draw the orbital radius now of Callisto, so we start at Jupiter, go all the way out, 1,883 kilometers to Callisto. This is exactly to scale. Callisto is as close to scale as I could put it. It's obviously 0.04 millimeters, so it's a bit difficult to draw, but it's roughly that size. Okay, so if you were looking, that's what you'd see. How can we make that a little bit better? I know, let's put the Earth and the Moon in. So again, to scale, the Earth is slightly bigger on this scale. Don't know if you can make that or not, it's not that important. The Moon is obviously even smaller than Callisto, and as we know, the distance between the Moon is 384,000 kilometers. So if you was to put the Moon and the Earth and Jupiter in the same position, when we look at the Moon, that's how far we're looking. When you look from Jupiter, you'd have to look roughly, let's say, 4 times further to see Callisto. Okay? So that's not where we went though. Let's make it a little bit more interesting. Remember I told you about this little picture and how I used to imagine the solar system in my head? Well, here we go. Now, if you remember the previous diagram, this was the Earth-Moon distance again, 384,000 kilometers. Then remember about 4 times the distance from Jupiter to Callisto was at 1,883,000. And believe it or not, when Earth and Venus are at their closest approach, this isn't always, but at their closest approach, they're just under 40 million kilometers away from each other. So if you used to get the distance between Jupiter and Callisto and multiply it 21 times, that would be the distance between Earth and Venus. So you are literally looking at a scale model, a scale graph at least, of the solar system. Interesting, eh? That's about it for now. Thanks for watching. Please give me a like if you've liked the video and subscribe, as this is the first video I've made. I plan to make lots of more little interesting videos on astronomy and the solar system and stars, etc. Thanks a lot. Bye.